Welcome, and thank you for joining this webinar, Anticipating Changes in Federal Methane Emission Standards for Oil and Gas Operations. This event is hosted by the American Association for the Advancement of Science's Center for Scientific Evidence in Public Issues. My name is Sarah Solomon. AAAS is the world's largest multidisciplinary scientific society with over 120,000 members from over 90 countries and nearly 250 affiliated scientific societies. AAA is also the publisher of the Science family of journals and home to a series of programs such as the Dialogue on Science, Ethics, and Religion, SciLine, the Local Science Engagement Network, and perhaps our most well-known program, the Science and Technology Policy Fellowship. We are proud to have over 3,000 alums of the AAAS Science and Technology Policy Fellowship, one of whom will be moderating today's discussion. The Center for Scientific Evidence in Public Issues, known as the EPI Center, is a program at AAAS designed to deliver clear, concise, and actionable scientific evidence to policymakers and decision makers. The AAAS EPI Center makes it easier for people to access scientific evidence and information, and then integrate that evidence into their decision-making process. We work on a variety of topics: green infrastructure, PFAS and emerging water contaminants, voting technology and election security, artificial intelligence, and oil and gas development, the focus of our webinar today. Methane emissions from the oil and gas industry account for 30% of global methane emissions and contribute between 8 and 13 million metric tons of methane to the atmosphere each year. Methane is a potent greenhouse gas that traps 25 times more energy than carbon dioxide. To achieve domestic and global climate goals, practical, cost-effective solutions are needed, and R&D, driving innovation, and new solutions should be incentivized. Today, we have much better data on where the methane emissions are coming from and how to prevent them from upstream, midstream, and downstream, whether it's drilling, production, gathering, processing, transportation, and distribution. Research shows that reducing methane emissions from oil and gas facilities helps avert climate risk, improves air quality, and creates jobs. Companies across the country are manufacturing the technology and providing services to monitor, measure, and reduce methane emissions. The methane mitigation industry is a rapidly expanding job market. Ground and aerial-based measurement tools make it faster and cheaper to locate, measure, and reduce emissions. In 2020, the International Energy Agency estimated that worldwide, the oil and gas industry can achieve a 75% reduction in methane emissions using technologies available today, 2/3 at no net cost. In June 2021, President Biden reinstated the Obama-era rules that regulate methane emissions from the oil and gas industry. The new administration also requires EPA to expand its methane safeguards to further reduce methane emissions from other sources within industry, both new and existing. These new methane regulations are expected shortly. Raising awareness about the scale and impact of methane emissions is essential to developing effective policy and protecting local communities. To discuss these topics and more, I'd like to welcome our distinguished panelists and moderator. Howard R. Dieter is Vice President of Environmental Health and Safety at Jonah Energy, LLC. Howard received a Bachelor of Science in Civil Engineering from Penn State University in 1989 and has over 30 years of experience working in a wide range of engineering, construction, and government relations roles. He is registered professional engineer in Colorado and previously in Pennsylvania. Prior to joining Jonah Energy in 2014, Howard worked as a consultant for several upstream oil and gas operators in the Marcellus and Utica shale plays and in Wyoming. Howard leads Jonah Energy's emission reduction efforts, including evaluating and implementing new technology to detect, measure, and ultimately reduce emissions. Jonah Energy was the first US-based company to sign on to the United Nations Oil and Gas Methane Partnership 2.0, which has as its foundational goal measurement to validate a company's emission inventory. Jonah Energy operates in the Jonah field, which is ranked among the top 10 gas fields in the US. Kate Konschnik directs the Climate and Energy Program at the Duke Nicholas Institute and is a senior lecturer fellow at Duke Law School. Kate is a climate change expert. Her work focuses on policies for reducing greenhouse gas emissions from the electricity sector and the oil and gas industry. Kate spent 3 months researching methane abatement policies at the International Energy Agency in Paris between 2019 and 2020 and serves on EPA's Clean Air Act Advisory Committee. Kate joined Duke University from Harvard Law School, where she founded and directed the Harvard Environmental Policy Initiative and taught oil and gas law. Previously, Kate served as Chief Environmental Counsel at US Senator Sheldon Whitehouse. Kate began her legal career as an environmental enforcement trial attorney at the Department of Justice. Uduak-Joe Ntuk is the 17th California State Oil and Gas Supervisor responsible for managing the California Geologic Energy Management Division, also known as CalGEM. He directs a statewide regulatory, technical, and field operations organization designed to emphasize the safe development of oil and natural gas, conservation, which includes protecting public health and safety, environmental quality, and the reduction and mitigation of greenhouse gas emissions associated with the development of hydrocarbon and geothermal resources in a manner that meets the energy needs of the state. He also serves as governor's representative to the Interstate Oil and Gas Compact Commission and as a governing board member of the Baldwin Hills Conservancy. Supervisor Ntuk earned his Master's of Science degree in Petroleum Engineering with an emphasis in smart oil field technologies from the University of Southern California, Bachelor of Science degree in Chemical Engineering from California State University, Long Beach, and an Associate of Arts degree from Long Beach City College. Dr. Arvind Ravikumar is a faculty at the Petroleum and Geosystems Engineering Department at the University of Texas at Austin, where he directs the Sustainable Energy Transition Lab. His interdisciplinary research examines technical and economic approaches to sustainably meet global energy demand while addressing its climate impacts. Specifically, Dr. Ravikumar's work focuses on the role of technology and innovation in reducing the carbon footprint of global oil and gas operations. He has developed leading environmental assessments tools such as FEAST, used by the industry to develop cost-effective emissions mitigation strategies. Dr. Ravikumar's public scholarship involves advising governments on oil and gas policy, providing expert testimony, serving in editorial and advisory roles, and engaging with media on issues related to the sector. He also holds fellow appointments with the Payne Institute for Public Policy at the Colorado School of Mines. Today's event will be moderated by Dr. Zachary Valdez. Zach is a Texas native, currently living in Washington, D.C., working with the Office of Advanced Manufacturing on promoting tech innovation, commercialization, and workforce solutions. Zach previously served as a science policy fellow with the U.S. Senate Energy and Natural Resources Committee. He earned degrees in engineering and physics from St. Mary's University and a PhD in biogeochemistry from Baylor University. During this time, he worked on heavy crude distillation at Southwest Research Institute and upstream exploration projects across multiple energy companies. Now, I will turn things over to Mr. Dieter, Professor Konschnik, Supervisor Ntuk, Dr. Ravikumar, and Dr. Valdez. Thank you.
Thank you, Sarah, and I appreciate the overview that you gave for our audience and AAAS for having all of us here. I really appreciate what AAAS is doing in providing scientific evidence in these public issues. And so to get things started, I just wanted to start with maybe Arvind, if you could tell us, give us a holistic awareness of sort of what and where the largest sources of methane emissions are in the oil and gas industry, and sort of, what the practices of venting and flaring, just quick and easy definitions of how those are incorporated and timescales and sizes, if you don't mind.
Sure, and thank you so much for having me here today. I think it's such an important topic, and addressing methane emissions from oil and gas operations is becoming a huge priority for governments across the world. And then thank you for AAAS for organizing this panel at this critical time. So Zach, the question you asked about methane emissions, that's really the million-dollar question. Finding out where and when are the biggest methane emitters from the oil and gas industry are happening. So I want to start by saying three things about methane emissions that will provide, I hope, a good background to what we're going to be discussing for the rest of the hour. The first thing is methane emissions from oil and gas operations come in three categories. These are leaks, vents, and flaring. Leaks are methane emissions that occur because of wear and tear in instruments, because things break and start emitting methane. They happen randomly in time, and we don't know when or where it's going to happen. Vents are methane emissions that are known to us and that are part of the operations of oil and gas production. These are vents that are designed for safety applications, that are designed to make sure that the processes are running smoothly. And in general, we know exactly where and when they occur and how much of methane they emit. There are some cases where a vent and equipment is not performing properly, and so a vent is supposed to be emitting 100 grams, for example, is emitting much more than that. Those we call anomalous vents. The last thing is flaring. Flaring is a process of burning natural gas. You do that for safety reasons. You do that when you don't have adequate pipeline capacity to take the natural gas that comes out of the ground. But in some cases, the flaring, which is the burning of natural gas, methane, to carbon dioxide and water vapor, is not 100% efficient. The flaring efficiency is a huge part of the challenge associated with oil and gas methane emissions. And the lower your efficiency, the higher the fraction of methane emissions that are directly vented into the atmosphere. So these are the three major sources of methane emissions. The second thing that we should remember is that methane emissions vary across space and time. The emissions in the Marcellus Basin in Pennsylvania, which is a dry gas basin, looks very different from emissions, say, in the Permian Basin in Texas and New Mexico, because it produces both oil and gas, unlike Pennsylvania. It also varies a lot in time. Many of the methane emissions that we talked about, whether it's leaks or vents, are not continuous. They can be intermittent, and they often happen without much notice. And so they vary in space as well as time. And the third thing I want to talk about is, and this is sort of the most important part for addressing methane emissions from the oil and gas sector, is that a majority of the methane emissions that we know come from a very small number of emitters. We call them super emitters. What I mean by this is that, let's say you have 100 leaks in your oil and gas field. The top 5 leaks, the highest emitting 5 leaks out of the 100, is likely to be responsible for over half of the total methane emissions. So the key to addressing methane emissions from the oil and gas sector is to finding and fixing these super emitters as quickly and as cost effectively as possible.
That's great, Arvind. I really appreciate that overview. And just to kind of increase on that, Howard, if I could get some ideas from you from an industry standpoint, what systems you use to detect and measure these methane emissions, and what technology specifically has Jonah Energy been able to use, and why?
Sure, thanks, Zach, and thanks to AAAS for hosting this. And as everybody, I think, acknowledges, there's a lot going on in the space for regulators and for industry alike. So I appreciate the opportunity to be here. We really, as an industry, we started looking at leaks several years ago, looking at various technologies such as OGI cameras to find leaks. What we found, what Jonah's experience has been, we conduct monthly inspections on our facilities using OGI cameras, and that has the opportunity to reduce the leak cycle time. I think it's important that these leaks that we do see, as was indicated, are definitely they have vary in time and they vary in space. So that's the first technology we use for leaks. Plus, we have a lease operator, one of our folks on site every day. And so they are doing four gas monitor and EVO type measurements and detections if something crops up. So we have a lot of eyes and ears on facilities on the leaks. Vents definitely can be solved with using technology such as instrument air, or to capture those vents and take them out to a combustor and burn them instead of venting them directly. That's a challenge for us in the field. We don't have any line power in the field. And so figuring out how to generate compressed air or other types of ways to run our controls to minimize vents is a challenge. We've been successful in consolidating facilities, though, and bringing production into a central facility, giving you fewer opportunities for vents and managing the production. On the combustors, two of the biggest things, one is the efficiency, and then one is not having the combustor ignited. We've seen that across the field too. So we have all of our pilot lights on SCADA, and we have immediate alarms if there's a pilot light not showing a temperature on it through SCADA, and that goes directly to our lease operators. So those are technologies on how we kind of detect what's out there. New technologies coming out involve fixed monitoring, and these are either VOC or methane sensors that are placed around the perimeter of a facility, and they can give you detections a little more frequently than sending someone out, once every 6 months or once every quarter to do an OGI inspection. There's some challenges in how you manage that data, understanding what it means, because you could get different detections on your sensors from different wind directions and so forth. And then we've also deployed fixed OGI cameras that give us kind of 24/7 look at what's going on at a specific facility, as well as some aerial detection through like Bridger Photonics and their aerial methane detection through LiDAR. Gives you a really good idea of what's going on with the facilities at any given time. And then we're working to figure out how to bridge the gap between what you expect to be going on with that facility on a temporal basis and what that measurement is actually showing. So those are some technologies that we're using in the field right now as we speak.
Yeah, and that's great, Howard. I'd like to ask you, is a lot of those technologies, whether it be aerial or on the ground, is that part of the 75% of reduction in methane emissions that Sarah had alluded to in the opening of her introduction, that could, reduce 75% of the emissions just with the existing technology we have?
From Jonah's standpoint, in our field, and there have been a number of studies conducted from University of Wyoming and other folks looking at our field in Southwest Wyoming, we have more lower emitters than we have super emitters. Our situation in our basin is slightly different than what you may see in other basins. And so we view our reductions for Jonah, I can't speak for other operators, but we look at a comprehensive list of all the various emission sources. And then we're looking at using technology on how to validate which emissions we currently report under EPA or One Future reporting, but also measuring other sources that maybe don't have a current reporting framework. And this is why we were an early adopter of OGMP, because OGMP has the ultimate goal of measuring and validating those measurements against calculations. And we think that's a really important step. We're supportive of it. We're working with the UN in development of the technical guidance documents in order to say, yes, this calculation for emissions associated with a blowdown vent are accurate, or they're not. And here's the difference, and here's the measurement that shows that. That's how we see reductions of emissions, and then certainly eliminating pieces of equipment that vent as part of redesign of facilities using other available sources and technologies. Those are the areas that we see we can make reductions in methane emissions.
Great, I appreciate you for clarifying that. And so, looking at it from a regular standpoint, Uduak, can you tell us a little bit more about how regulators choose of these systems that Howard is kind of relating to, but maybe on your end, what systems they use to detect and how those results are validated over time, and where you've seen sort of technology come from in terms of ground and aerial based abilities to measure?
Thanks, Zach. It's a pleasure to be here. Yeah, from a regulatory perspective, we always have constrained resources. And so whether limited people or limited budgets of technology, it's really what is the most affordable and what is the kind of more mature technology. We're fortunate in California to have partnerships across multiple jurisdictions that we work really well together. We have JPL NASA will do airplane flyovers, aerial flyovers for us. We do have in our inventory, CalGEM, we have kind of 4 geographic areas that we were able to purchase FLIR cameras, which are about $10,000 a camera for each of our areas to go out and do part of our on-site inspections. But as Howard mentioned earlier, you usually start with the biggest emitters. When we get a report out from the aerial flyover of what areas or what fields are having the highest emissions, and that's where we send our inspectors to go follow up on and verify. We also have authority to send out to operators requesting them to do an inspection and a root cause analysis back to us. But we also have recently developed a pilot program for methane drone flyovers that we've been using in Southern California or more populated areas where the drill sites are more condensed. One of the questions is, what kind of field do you have? What kind of operations? What's the geographic, spacing? It's much easier in a very consolidated 1 or 2 acre site to do a drone flyover versus hundreds or 50-mile field that is very difficult, or you have to wait for you to get aerial information back. So it's a mixed bag of what's available, what type of operations you have. And in California, we have a lot more steam flood and heavy oil operations, very different than Permian Basin or Pennsylvania. And so we try to look at what are the fields that have higher associated gas production, which is likely to have more volatile and potentially more methane emissions.
Yeah, I appreciate that. And do you find that sort of your measurements, if you're allowing some self-reporting on the industry side, do they usually align? Is it a benefit to both of y'all to have that open line of communication to say, hey, we've noticed this on a recent flyover, can you double check? Or how does that relationship build over time? And what have you seen sort of using technology to kind of align best practices?
Yeah, in California, we've had a leak detection and repair program going on 4 years now. And so it is self-reported, but it's every quarter have to go through every valve and potential leak point or flange or tank top and report out. So that's been a good sense of creating a database or repository that we can look back over time for changes. But we do have, I think, a collaborative, if we get a high emissions reading and we send the notice, we've been able to follow up with the operator who brings on the manufacturer, who's been able to work with their engineers and operators. That the challenge with methane is it's odorless, it's invisible, and so really, if you don't have the technology, whether the right type of sniffers or 4 gas meters, or fixed open path meters, that it's laser detection, it's difficult to know it's there. And so but we've been having success everywhere we've been able to find it, to work with the operators and go back and follow up to confirm that it's been repaired, reduced, the tank tops closed, and so forth.
Yeah, I really appreciate that. I kind of think of it as like growing up in Texas, like where are we leaking air conditioning in our house and where's it getting out? Is it cracks underneath the doors, the windows, those sort of things. And so I'd like to move to Kate and ask you sort of, if we were kind of focused in on like the granular aspects of the technical and the instrumental aspects of these leaks, but are there bigger outstanding questions that we want to know, research or otherwise? And what can we do to address some of those data gaps?
Sure. Thanks for the question, Zachary, and thanks for inviting me today. This is super interesting, and I'm honored to be here with these other panelists. I am, as Sarah said at the outset, trained as a lawyer, so I don't come to this with such the technical background that the other panelists have. Instead, I'm sort of thinking about the question that you posed through the lens of policy design. What information do we need about the nature and magnitude of these emissions to design more effective policy to get reductions of methane? And so when I think about that, there's sort of two big things. One, and I thought it was super interesting, Arvind, you had said that you have from the scientific perspective, you have a pretty good handle on emissions coming from vents. Howard, though, had also mentioned the sort of some of the events associated with particular activities having to really sort of corroborate what we've expected with our emissions factors and what actually is coming out. I do think more information about different types of activities that result in vents could be important. I think in California, there's now for liquids unloading an option, right, for the regulated community to either capture those emissions or to meter them so that California has a better sense of are our emission factors, are our estimates in the ballpark, or are there sort of broader distributions here? So I think a little bit of work on venting still may need to be done, and it might be that it's from a policy perspective. The policymakers, I think, were a little bit late to the game in focusing on vents. The focus has been mostly on leaks. I think some of that is Howard and Arvind, I think both mentioned the safety reasons for venting. And so I think there's been some concern about encroaching on what has been standard safety practice. And yet, as there are new technologies and abilities to capture that methane and keep the workplace safe, but also keep those emissions from entering the atmosphere, that's a really good place to be moving forward. More generally, really big picture moving out, I think we are learning a lot. It has been amazing how much information has been collected and studied in the past, even just 5 years. I feel like that sort of what we know about methane emissions from the sector has just exploded. Excuse the pun. But I think we still could go further in finding out exactly what the total magnitude of emissions are and the emissions distributions. Basin by basin, to Howard's point, it's very different, the geology basin to basin. Uduak's point about, the flooding and the heavy oil wells having maybe a higher methane impact. So, this is going to be very different basin to basin, but I think getting a better handle on emissions distribution so that we can feel comfortable that we have a certain expectation of what the total emissions are. And when we do certain policy interventions, that we can expect a certain amount of reduction as a result of that. I think once we have a better handle on that, and we already do have a much better handle on it today than 3, 4, 5 years ago, I think that opens up the door to much more effective and cost-effective regulatory models, thinking more about performance-based and output-based, so that the regulation can be keyed to how many tons of methane are going into the atmosphere rather than how many widgets can we replace or turn a wrench on. And then one thing about how we could collect that data, we've been hearing about collaboration across the scientific and regulatory and industry communities. I think that's hugely important. I also think strictly from a regulatory perspective, and since we're here talking in part about the EPA rule, I think we could do a better job aligning some of these regulatory regimes so that, for instance, EPA's greenhouse gas inventory is speaking to EPA's regulatory provisions so that companies that are reporting in one space, that information is flowing to the other as well and helping inform either compliance with regulatory obligations or our national inventory.
No, I really appreciate that. I think that, communication across, whether it be between industry and academia or regulators is important, but also within government to make sure that we're not replicating studies and resources and making sure that we're making best practices come to light. And so, I like the idea of how do we incorporate more innovation and technology and not be worried about replacing things, but looking at the bigger picture. Arvind, do you have any sense of the current technology? I mean, Howard mentioned a few of the things, and please speak at like a colloquial level about, I didn't get on you, Howard, but you mentioned like ICS and a few of those acronyms that some people may not know, but if you could talk about some of the technologies that are currently available and maybe what's coming down the line to look at methane emissions and across the supply chain, right? So we've kind of been focused on I guess you could say the upstream or the exploration of where we're getting the oil and gas out, but there is issues across the supply chain. So I'll leave it up to you, Arvind.
Right. That's a great question, and it follows very nicely from what Kate had just talked about in looking at better understanding emissions distribution across different spatial and temporal profiles. For example, emissions in California will look different from that in Texas, which will again be different from emissions we have in Pennsylvania. That said, and it might be a little strange coming from me as an academic, we cannot wait for perfect information to start developing effective methane mitigation strategies, because we know enough about methane emissions from the oil and gas sector over the past few years. There's been a ton of studies looking at this issue that we know where the biggest sources are and what we need to do to address them quickly and cost effectively. And in fact, that's exactly where new technologies actually come in. And I want to rephrase that a little bit, because it's not new technologies in itself, it's new solutions. And the difference between technology and solution is this. A solution is a combination of a sensor that detects methane plus a platform. For example, you can put that sensor on a drone or a plane or a satellite, and the analytics behind it to understand the data that the sensor collects and convert that into meaningful information about leaks, their location, and what's the way to mitigate them. So what we need are better solutions and cost-effective solutions to address methane leakage. Sure, technology is a huge part of it, but that is just one part of it. We need the right platform and the right analytics behind it to be able to really move from detecting methane to actually mitigating methane emissions from the oil and gas sector. That's the first point. The second point I want to talk about is, as much as it is a cliche, there is no one size fits all to the methane mitigation problem. The diversity of sources of methane emissions, from the production to processing to pipeline transmission and to our distribution systems, are very large, and you want solutions to be tailored to those specific segments of your supply chain. For example, if you want to detect methane leaks from interstate pipelines, you obviously need a technology that can do it quickly over very large distances, because pipelines go thousands of miles across the country. But if you're looking to find methane leaks, say in a processing facility or in a refinery, that's a very dense piece of equipment in one location. So you might have a lot of different sources that you need to be able to find in complex environments. And so there's no one size fits all solution, but you're going to have to match the right solution to the right location and the right type of facility that you have. For example, there are technologies that might not work as well when you have snow on the ground. So those technologies cannot be deployed in places like North Dakota when you might have extensive snow cover during the winter months. So choosing the right technology that also takes into account the location of those facilities is important. And the last thing is that what we find typically is that the choice of your technology is going to depend on what you want to do with it. Let's say your goal is getting an accurate inventory of methane emissions. So you are most concerned about the accuracy of the quantification of methane. So you want to choose technologies that can give you a very good number with reasonable uncertainty of what the methane emissions are. Let's say your goal is doing repairs. Then you really want to know exactly what component is leaking and how do you go and fix them. And what we find in field studies and initiatives by the industry is that often a hybrid approach is actually effective. So for example, you can take an aerial technology and fly quickly over thousands of sites, whether it's a well site or a compressor station, and find out which of those sites or stations are emitting large quantities of methane. And then once you do that, you can send a follow-up ground crew to those sites to figure out exactly what component is emitting so that you could repair them quickly and effectively. So the solution to addressing the methane problem is going to come by leveraging all of the new technologies that are currently available. There are sensors on drones, on planes, on satellites, and fixed monitoring sensors that Howard talked about. These are all going to be useful in one way or the other. The challenge is to finding the right applications for these technologies so that they all together help us address the methane emissions problem.
Yeah, thank you, Arvind. I think that's really neat because, you mentioned all these technologies exist, but I'd like to kind of switch to Uduak, who had mentioned although they exist, there's still sort of that resource issue, whether it's personnel or technology or pure funding. And so, from a regulator standpoint, how do you overcome some of these or find some of these solutions, as Arvind has mentioning, to understand a little bit more about building an evidence case for what methane's the various methane emissions that are out there?
Yeah, I think part of the different regulatory approaches is setting stretch goals or bold goals that might be earlier or maybe uncomfortable for the regulated entity or industry, because that's going to force them to look at creative solutions to get there sooner and faster. I think the sooner the rules happen and that we can build off of other states' lessons learned or findings can help with any new rulemaking. And I think the flexibility of, similar how Kate was talking about, like connecting it to the goal, like we want 20% or 40% emissions reduction, but you can choose, do you want to do fixed sensors? Do you want to do some new technology that we may not be aware of? Building in the flexibility, we want the right output, and maybe the size of your production and your facility or the type of production, you need a definite method to get there. As long as you get there, and it's a trust but verify. We want to put the onus on the industry to comply with the regulations, but we need to be able to verify that it's really happening and it's not a trick of the cards. One thing to think about as far as kind of spurring innovation that happened here in California, our South Coast Air Quality Management District had a AQ sensor conference where they solicited air quality
Thank you.
Air quality specification, a sensor conference where they reached out to the different manufacturers and had them bring forth the different types of sensors, and they reviewed and validated and made a recommendation and had papers from the companies, from researchers, brought the regulated community together. And it was really, and it's all online. It's like, if someone's looking for, I need to comply, but I don't know how, here's a set of 5 validated sensors that you could use that's available. And that way it kind of takes some of the mystery of, you have this new rule, I don't know how to comply. Well, here's a whole conference on all the different options that you can choose what's best for your operations.
Yeah, I really like that, helping, as Arvind had said, using science to find solutions and apply those solutions. And so, Howard, have you been able to address some of these solutions and find these conferences and build out a lot of where you can collaborate with what regulators are doing in industry and technology to kind of gather your holistic solution to methane emissions?
Yeah, we certainly have, and it's a pathway, not necessarily, I can't say we've checked the box yet, but I think we're on the right path. And I apologize for the acronym, OGI, optical gas imaging. So an OpGal camera or FLIR camera would fit that bill. And I think my colleagues have expressed this extremely well. We think about this whole process as a program, taking and applying technologies, and different technologies work for different things. We have very, very small leaks associated with, or actually not even leaks, but vents associated with our pneumatic devices. Those are difficult to be detected or measured with certain technologies, but we can measure them with a high flow sampler put onto those vents. Things like coming out of emissions out of the tank or out of the manifold system of our tank collecting waste gas. Those can be seen with a handheld optical gas imaging camera, or we've been deploying a drone-based optical gas imaging camera since 2018. They can be seen through aerial methane detection technologies, and in many cases, they can even be seen through satellite imaging. And so how you build this continuum of ways to measure and how you compare those measurements against your various emission sources, I think is really important. And I did want to address, there was one question that came up in the Q&A, had to do with the definition of facility. Everybody's is going to be slightly different, but ours definition, when I talk about looking at a facility, it includes a separator building, it includes a dehy tower, and it includes a tank battery. And in some cases, it would include well site compression, which allows us to reduce the operating pressures of the systems, which also takes a little bit of pressure, so to speak, off of emissions. If you have some sort of a leak, the higher the pressure, the more you're going to be leaking. The lower the pressure, the less you're going to be leaking. So this well site compression has allowed us to do a few things: consolidate these facilities, which are basic three-phase, three-step separation of gas and liquids and dehy dehydrating your gas. So it's allowed us to consolidate those, which eliminates sources that have the potential to vent or are permitted to vent, under the stationary source permit process. But it's also reduced pressures within the system, which also has the ability to reduce the amount of leaks if you do get a leak off of a process. So bringing all these technologies together is extremely important. Understanding all your various emission sources, not just those that are reported through various state and federal programs, but understanding all of them also allows you to quantify them and allows you to think about how you deploy limited capital in fixing the things or eliminating the things that have the biggest opportunity to be an emission source. And I think that's the ultimate goal of at least of our program, and I think it should be for any program that an operator has, isn't just the detection of a vent or a leak, but it's ultimately how do we change what we do to eliminate any vents off of this system or any leaks off of the system. And that has to be the ultimate goal, is reduction.
Yeah, and I just want to piggyback on that. Are there particular methane reduction or climate commitments that Jonah Energy in specific has made? And did you have an idea of why or how those were made?
So we're an independent operator, so we don't have the same types of shareholder pressures that other operators have, but we do have customers, and almost all of our gas goes to the West Coast or Pacific Northwest. And so our customers are demanding that we look at methane emissions and ultimately, CO2 equivalent emissions of our operations to provide the cleanest fuel supply that we possibly can into power generation and heating and cooling needs out to California, out to Oregon, out to Washington, and some of the states in between. So we have set an internal goal for methane reduction. We have looked at our overall methane emissions, and from 2018, we've had about a 60% reduction in the amount of methane emissions associated with our operations through measuring and validating what we're reporting, through managing and modifying our facilities. We are part of One Future, and so we do look at an emission intensity as a percentage of gas throughput, utilizing the One Future calculation, which includes some additional sources in the entire value chain above and beyond those reported through the EPA greenhouse gas reporting protocol. And then we also have, through OGMP, are building an overall comprehensive, here is our complete emission profile, and here is the measurement validating that complete emission profile. It's what our customers are asking for, both domestically and internationally, and we think it's really where it needs to get to. All of our employees at Jonah are held accountable to that methane emission reduction standard, and we've created a methane team or an emission reduction team internally that involves some of my staff and also some of our field operations. So we have the give and take on what's possible from a field operations standpoint, but also what do we need to report to our executive team and to our board.
Great, thank you, Howard. And so, Kate, to kind of piggyback on that, is there a way that different regulations or rules from companies, as well as looking at more of how much of those technical measuring and monitoring detection processes do these decision makers need to understand to establish adequate protective standards? So one's on the industry side, what are they doing what's different about their outcomes? And then one's from the regulator side is, what do they need to understand to make better standards or adequate operations for these industry partners?
Yeah, well, I think, and hopefully this ties together everyone's sort of comments on this, because I'm thinking back also with Arvind's opening point here. I mean, we know enough about methane emissions to regulate right now, whether it's corporate policy regulating the emissions or state and national governments intervening. But the nature of those policies tend to be focused on inputs, right? So we go to where we know the sources are, or we deploy known technologies to walk around periodically, and now we're starting to deploy aerial surveys to find the leaks when they're intermittent and we don't know exactly where they might be. I think the ultimate goal, at least in my mind, would be to let's regulate the inputs while that's the best sort of framework we've got. But as we get a better sense through these technologies of periodic aerial surveys complemented by real-time sensors on the ground and periodic physical manual walking around with OGI and other similar handheld equipment, when we get that better sense of a regulator like Uduak saying, I now trust that when a company says this well pad is emitting X tons a year, we feel confident that that's in the ballpark. Then you can move to this sort of outputs rate-based regime where it's about the total tons that are hitting the atmosphere and limiting those. And then in those kinds of regimes, whether it's deployed by Uduak at a state or by EPA or by management at Jonah, you can really activate your engineers, right? You're not telling them go switch these valves to low emitting. You are saying get rid of the biggest tons as cheaply as possible. And then you've got a lot of people in different problem solving modes. So whether it's, some companies have started, and I don't know if Jonah is one of them, but some of them have started including in some of their middle management bonuses whether your team has reduced methane emissions, right? So you could do that in the private sector side of this. Public sector, regulations that like Mexico has implemented, like Canada is moving towards, like we've seen for some segments like Colorado for midstream, where you start setting a performance target and then you let the companies figure out the best ways and the least costly ways to get those tons out of the atmosphere. So I think today we absolutely can be regulating the sources that we know of. Our technology is getting better at spotting those leaks that we don't know where and when they'll pop up. But I think ultimately we want to move to this place where all of us, regulators, policymakers, industry, are confident in our estimation of emissions leaving particular facilities such that we can environmental regulators can set an environmental target, and then the engineers at the companies can figure out the best way to meet that target.
Go ahead. And I really like that because I like to touch maybe on, from a geographical standpoint or even from a jurisdictional standpoint, how do those differences matter in terms of what their behaviors or their emission standards? So we've talked to Uduak out of California, but there's Texas, there's, South Dakota was mentioned, we have Pennsylvania. How do those different areas or even from the local to the federal level, what evidence-based policies are out there?
Yeah, super interesting question. So in order to move to more either pollution fees, so market-based mechanisms, or performance-based, these output-based kind of regulations, we for the most part have to leave this country or look at other types of industry that we've regulated. So performance-based regulation is still pretty new in the American oil and gas space. And it's for exactly the reasons we've been talking about, of everyone wanting to be more confident about what the emissions profile is and what the distributions are before we start setting regulatory requirements of don't emit more than 2% of throughput, don't emit more than X percentage below your baseline, because nobody can agree what the baseline was. And so you have to sort of look elsewhere for those analogs. But we have seen when we shifted from sort of command and control, put this piece of pollution control on coal-fired power plants, for instance, and moved to more of a market-based regime where it was, here's the total tons of pollution that this industry can emit. Now you figure out where to get the cheapest tons. We have seen companies over comply with those caps throughout the years. They obviously, they've taken some criticism. It's not like everyone is 100% full fans of market-based mechanisms, but it has seemed, at least in that industry, that we've seen faster reductions than we expected at lower cost. This is a tough industry though, so I will just put a pin on that. So for instance, Norway has been relatively successful at reducing emissions from its oil and gas sector with a methane fee in its carbon tax regime that it's had in place. So they're obviously not as big a producer as us. They produce about 15% of the oil, about not quite 20% of the gas, natural gas, but they emit about 3% of our methane emissions. So they are doing much better than we are. Is it because of the fact that they have a market-based fee regulatory regime versus the sort of scattershot, state by state regulations that we have? Or is it that they have a completely different context in which that particular policy regime was able to come forward? It's a relatively homogenous industry there. It's big offshore platforms. There aren't that many actors. They're all really big, well-capitalized, savvy, very, very different from the highly competitive, very diverse landscape we have in the US, both from the business standpoint and from geology. So very hard, I think, to tease apart sort of, what is the reason for success in any one jurisdiction? Is it the luck of the geology? Is it the right mix of corporate actors? Is it the policy overlay? Really unclear, but it does seem when you look at analogs of performance-based regulation of other sectors and in other jurisdictions, you can generally conclude that those are a good way to really sort of activate creativity in the regulated community and get reductions faster at lower cost.
Yeah, thank you. You're right that it's a blessing and a curse to have so many different operators with innovation coming behind how we explore for different energy resources, where in other countries it may be done differently. Arvind, can you roll off that and tell us maybe in particular, at least from the United States standpoint, are there particular methane emissions that have been underestimated? And does that affect regulatory behavior, or more specifically, what can be done to address those methane emissions that may be underregulated?
Yeah, so here's the main challenge. Kate brought up the example of a coal plant. We know that irrespective of where the coal plant is located, roughly you're going to get about 1,000 kilograms of CO2 for every megawatt hour of power generated. So when you have something like that, when you know what the emissions from a coal plant are going to be, it's much easier to regulate them with a threshold or with a performance-based standard. But methane emissions is not like that. For every billion cubic feet of gas produced, for example, you can have companies that are emitting less than 1% of the gas produced, and you can have companies that emit more than 5% of the gas produced. So there's a huge difference in emissions because of the nature of methane emissions from the oil and gas sector. So performance-based standard can be effective and can give rise to innovation from different operators, but it is also a unique challenge to do in the oil and gas sector because of the nature of emissions. And I think this is where new technology and new solutions are changing the field for improved quantification and estimation of methane emissions. For example, we published a paper recently in Nature Communications. Jeff Rutherford from Stanford was the lead author on it. We looked at EPA's greenhouse gas inventory. We know that it has been underestimating oil and gas methane emissions by about 60% compared to field measurements. And we went in and looked at why is the EPA underestimating methane emissions. And what we found was that it is a fixable problem. For example, in very short terms, EPA has two different factors that they multiply to get methane emissions. One is the activity factor, which is the number of equipment or components you have, multiplied by the emissions factors, the average amount of methane emissions per equipment. What we found is that some equipment, like tanks, for example, are one of the largest sources of methane emissions out there. And EPA emissions factors for tanks are much lower than what we observe in the field. So when you update those emissions factors, when you update those activity factors, you can actually bridge the gap between the inventory estimates and field measurements. And so yes, with all the new technologies and platforms that are coming in, we should be able to get better methane estimates, methane emissions estimates, and therefore have the potential to move towards a performance-based standard. But again, whether it's doable has to be done only with continuous and updated measurements of methane emissions. We cannot do paper calculations and say that this is what the emissions are. We have to go there and measure emissions and use that number to figure out what our next best policy is going to be.
No, I couldn't agree more. We have so much technology and the ability to gather data that we really need to utilize that. And so, I'll leave, Arvind, I want to give you maybe 30 seconds each to kind of answer this last question, but for each of you, Arvind and then Howard, Uduak, and then finish off with Kate, is there evidence that you think that need to be incorporated in this soon to be released EPA methane emission standard?
Yes. Yes. until recently, EPA has not incorporated some of the new technologies that have been developed over the past 5 years, and including them as part of the new regulations will significantly improve the cost effectiveness of methane regulations. That said, there's no substitute to regulating the entire industry to address methane emissions as an entire country.
Thank you. Howard?
Yeah, I agree with that. And going back to something that Kate had touched on, where we operate in Southwest Wyoming has an winter ozone issue, and it's a fairly unique thing there. And we've been very successful at reducing the contributory emissions of VOC and NOx through both more stringent regulatory environment as well as voluntary measures that operators put into place that are specific to their various assets. And I think that needs to be the model, is having a consistent regulation, but also incentives for voluntary measures above and beyond those regulations where operators can reduce emissions. I think the regulations that are going to be coming out for methane, they absolutely are necessary. I think they need to include measurement for validation of the calculations, as Arvind had indicated. It is the basis of OGMP, and I think it really does need to be the basis of how we move forward. There are a number of these technologies that have applied for dispensation under the current EPA regulations, under the alternative means of emissions limitations. And I think that including those technologies into the new regulations is going to be really important for operators.
Thank you. Uduak, do you have any last remarks on that?
Yeah, I would hope that the 10 states that have methane rules are examples that are built on, new versus existing. As we cover both in California versus Wyoming and Texas are only new, making sure that there's a broad components are included, flaring, pneumatics, onshore, offshore, low production wells. Those information will help us get a broader and better picture of a national rule.
And Kate, do you have any?
Yeah, I would say in addition to making sure the technologies that we know have matured since Quad OA get included in this new rule, I'd also like to see maybe a more specific process by EPA, particular models that they reference or something, so that we know for the technologies of tomorrow, we know how we could get them improved and brought into the regulatory regime as well. And I'd love to see something on unlit flares.
Thank you. Very precise. I appreciate it. Well, I'm going to close it out. Sarah, would you like to have any last? First, I want to thank all of our panelists. Y'all have been great, super informative. I hope everybody else can find you on whatever resources you have, but I'll leave it up to Sarah to go ahead and close us out if you'd like.
Thank you all for your thoughtful answers. Today's discussion has been insightful and educational, everything we hoped it would be. There's obviously so much more to be said and more questions to be answered, more to be done. Unfortunately, we are out of time for today. I want to thank our panelists and our moderator, Mr. Dieter, Professor Konschnik, Supervisor Ntuk, Dr. Ravikumar, and Dr. Valdez. Thank you for your time and your willingness to share your expertise with us here today. And to our audience, thank you for your time as well and your attention. The EPI Center endeavors to make it easier for policymakers and other decision makers, yourselves included, to access relevant scientific evidence and then integrate that evidence into the decision-making process. We hope you have found this discussion helpful, and we very much appreciate your feedback about what was discussed today. There is a survey in the chat and will be also sent around afterwards. If you would like any more information, if you have outstanding questions, please feel free to contact the EPI Center at epicenter@AAAS.org. We are also on Twitter. So thank you all and have a nice day. Goodbye.
Thank you.